Hello, my name is Timothy Gallagher, and this is my Physics 2 Lab 3 magnetic field of a bar magnet. In this experiment, we will be exploring several concepts and using several equations, the first being the Biot-Savart law. The Biot-Savart law is an equation relating the magnetic field generated by a constant electric current. It relates the magnetic field to the magnitude, direction, length, and proximity of the electric current. The Biot-Savart law is fundamental to magnetostatics, similar to that of Coulomb's law in electrostatics. We will also be exploring the distance dependence equations that relate the magnetic force to distance from any given point. In this experiment, they will be used from the bar magnet to the location of measurement. In addition, the net magnetic field will be explored and how multiple magnetic fields combine. In this lab, we will align the measurement device to true north in order to account for this. The Biot-Savart law and distance dependence equations can be seen to the right and will be used throughout. After performing the experiment, we can see the results here. The averages are automatically calculated after inputting my 3 observations for each section. The natural log equation I calculated is negative 2.553 minus 13.735. The BNet calculated is 0.001617. The calculated distance is 0.2453 meters. With this, we can calculate mu to be these results used later in the lab. When calculating the magnetic moment, we can use the Biot-Savart law. Calculating for K, we obtain 1.08 times 10 to the negative 6th. For this, we can calculate mu to be 2.893 am squared, and it was done using the Biot-Savart law equation to the right. Observations. The first observation I identified was when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. I found this to be true based on the results in the experiment. Second was, as the magnetometer moves closer to the magnet, the measured x component of the magnetic field decreases. I also found this to be true. I did not find the third and fourth observation. The position of the magnetometer has no effect on the measured x component of the magnetic field, and as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. I found these both to be not true. Now for the computational model. Here we see the results utilized from the experiment in the Google script code. To the left, we see the model for the experiment with the blue arrows showing the magnetic field on axis and the purple arrow showing the perpendicular magnetic field. The small purple arrow to the top right shows the magnetic field at a 45-degree angle. We can also see the output of the magnetic field at the observation location to the right. For discussion, what if you hadn't orientated your experiment to compensate for magnetic north and instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would the results have changed? And without orientating for magnetic north, our initial x value would not have been 0. So calculations would have therefore included the Earth's magnetic field and the field from the bar magnet. So you would have to do net magnetic electric field, and our results would have been less accurate. Next, what if you were to stick 2 identical magnets together end to end and run the same experiment again? How would you expect your measurements to differ? And for this, the magnetic force would increase, but we wouldn't necessarily say it would be double, but we could say with certainty that it would increase to a certain degree. Thank you. This has been my experiment.